schedule 2017 this semester. So I think the Monday, Wednesday, beginning 9. Okay. So this one. So our exam is scheduled on the Monday, 10:45 a.m. to 12:45 p.m., which is the December 11th. Okay. Then, if there is any conflict schedule with other classes, you need to ask the other class to change the schedule because it's assigned, the scheduled by the registrar office. But actually, the whole class follow this assigned schedule. But sometimes there are instructors who change the schedule by themselves. Well, in conflict situation, I cannot change my schedule because it's assigned. Okay. Then the exam will cover after the midterm exam, which will be chapter 7 through 13, whatever we cover after the midterm exam. So midterm will not be it's not comprehensive exam, so we don't have to worry about the midterm, only after the midterm exam. Okay, so then pretty much the 1 or 2 days later, there will be the open time to check your final exam sheet. However, after the exam, so I'm not going to take any appeal on the grading, the others, which means to only take the appeal for the final exam. So if there's any issue or the mistake or the problem on any class activity, so you need to contact GA or me before the final exam. Okay. The reason is that also I'm going to leave for China to teach the computer science course in our sister university. So I do not have a time to take care of the complaint after the final exam. So please check after the Thanksgiving, check any mistake or the issues on the grading. Okay. And today, so we are going to finalize the chapter 12 regarding to the file system implementation, and followed by the GA's brief on the second project, the portable file system. I already explained in the classroom, but he will compile and explain what you guys need to do. And also, pretty much, I think that we have a time today to take the quiz that we missed the last 2 classes, which is chapter 12, 11, and today's class chapter 12. So, if you are asked to implement a file system like the project 2, for instance, so I'm going to use our portable file system for your better understanding. So this is our computer, and we have the memory. It's our memory, and we have the secondary storage, and the operating system is running on that. So to manage the number of files on our hard disk drive, we had, instead of using the physical devices, so we are going to use the file system. The file system is on top of it's a part of the operating system. Okay, so for example, NTFS, ESP2, 3, 6, 8, and so on. And extended file system, or UFS, NFS, GFS. This is your general purpose file system. In addition to the general purpose file system, there are a lot of file systems that sometimes we may not realize there exists such a file system, like the temporary file system, process file system, and the blah blah object file system. There are a lot of file systems. So then, what we are going to implement in this project, in this chapter, is our own file system that that will not replace the existing file system. It's running on top of the existing file system. So something the click itself. So anyway, so which means let's say this is our NTFS in your operating system, like the Windows, and NTF file system, our PFS file system will be exist as the file in terms of NTFS. For example, this is the one.pfs file. Okay, this is our file system. So the default size, the initial size is for example 10K. You can create it's nothing inside. We pretend that this is the empty file as a hard disk drive or the SSD. So as we have learned in our chapter 10 and 11 regarding to the physical hard disk drive, so the physical device will be managed by after formatting. It will have a number of the block. It's a logical block number or the LUN, logical block number, logical unit number. So LUN will be used. For example, it's a block number 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Depending on the block size, you will have the number of blocks. You don't have to do anything for this one. You don't have to draw the line, or just define. The block number 0 is from the offset 0. This is the offset. This is a block number, and 0 to 255. In case of the 256, the block size. Okay? Actually, you don't have to do anything for the file, but we consider from, for example, offset 0 to 255 is a block number 0, and block number 1 is 256, and so on. So you can manage this information somewhere in your program. Even you don't have to store this information. You can easily calculate, right? So you don't have to do anything, but you need to define in your program design. This is your block and the number of blocks. Then the next thing is the file system consists of the two main parts. One is a file. Another one is the directory structure. For the file structure, we are not going to define the new file structure. We are going to use any files that are being used in the primary general file system, like your operating system file system, NTFS, or the ext3, or 6, whatever. So you can use, for example, I have the a.txt file. We are not going to directly create on the files PFS file system. Instead, we are going to use the existing files on the NTFS. For example, that upload to here by the commanding, right? So we will implement the put command, get command, and so on. So these are the method, the functions that you are going to implement in your pullover file system. This mechanism is used a lot in the file system. For example, you heard about the Hadoop file system, distributed file system for the big data. Hadoop, HDFS uses exactly same the mechanism. They provide the Hadoop, the command, share command. Then you can upload and download and release such a or remove such a file. Okay, so the structure of the file is okay, but once you upload the file, you need to manage such a file from the PFS, not the NTFS or the general file system. To do that, you need to define FCB. So instead of accessing all the file information as a metadata, that metadata will be managed by your own FCB. So you need to define this one as the first one. So if you have a number of the file, you will have the number of the FCB. So how to manage this one? This is your design. Okay, that's one of your main jobs. So then this one should be, if you have number of the FCB, that is the number of files on your file system, that will be the problem of the directory, okay, or folder. But in our total file system, we will use just a single level, the directory, which means you don't have to create the new directory structure. Instead, we are going to use as a one single level directory structure. That doesn't mean we ignore the directory structure. We use the single level, which means you don't have to create anything, just manage the number of this one. But the question is, where do you manage this information? So for example, I upload the a.txt file to our PFS, then create the FCB, then where is that information? You can manage it on your program, which means the memory structure, but it should be synchronized to the somewhere in your file system, which is the directory structure. Okay? Even though we do not explicitly implement the directory structure, this information, any information should be written to your file system. Many of the students ignore this part just from the program, which means memory. So you instantiate object, okay? Then create one FCB, another FCB, another FCB. However, if you shut down the file PFS program, you will lose all the information. So when you start it again, you need to start the initial. So whenever you just like when you put the file to your PFS, you will write this file a.txt file somewhere here, right? So similarly, you need to write the FCB information. It can be the different ways. You can directly in place writing. You can directly write to the hard disk drive the PFS, or from time to time default writing. You can do the default writing, or when you shut down, exit your PFS program, then synchronize. Okay? So you need to do, otherwise you will lose all the information every time. Okay? So please keep in mind this part. So FCB and directory structure is not mentioned in the requirement, but it's a single level directory. Even though you do not explicitly implement this one, eventually the set of FCB will be directory structure. This will be stored somewhere here. And what else? You need to define the method, how to allocate the block for the file. We learned the last time, contiguous, extend, and index, the linked. Among them, I ask in this project only contiguous, which means the first time, all of them are available. You need to manage it. Available contiguous block. We will discuss today how to manage the available free blocks today. But once we know where is it, then allocate. Then you need to manage. You need to manage it on your directory structure. Actually, this is called the header information. Header of your metadata of your file system. Okay? So you need to, actually the most of file system use the directory structure to manage such a metadata, but in our case we do not explicitly implement the directory structure. So for example, I'm going to use the one block for the directory structure or header information your file. And this is a 256 byte, offset 0 to 255. Okay, then first 10 byte used for the name of this file system. And the next, the 11 to the 100 will be used for FCB. And the next 1 to the something will be used for the free block. Okay, the others are the blank for future use, something like that. You need to define, design, outline, or whatever. So you need to design this one in your program, in your implementation. This is one of the important part. Okay, many of the students ignore. Then just implement this, and through the memory base. It's only in memory-based file system, but you will lose information when you log out. So please keep in mind the design of the disk. It's not named because if I ask this is a directory structure, it will be much more complicated. So that is the reason I do not name it, but you need to implement some header block. Sometimes you can use a 2 block or 3 block, but it's up to you. So you need to define the information. Okay, so I probably covered the most of the part except the how to manage the free blocks. Which one is free, which one is used. Okay, so very simple. How do you know which one is used, which one is not used? So for example, we have the 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5. So around 42 seats in this room. 42 available seats. So whenever we have a student who I need to take a look at and search which one is empty, which one is not, yes, I can do that, but it will take a long time. So, for example, if you upload the file, every time the file is uploaded, created, so if you check each and every block, which one is available, which one, how many contiguous the available block, it will take a time. When you have small, that is okay, but when you have a large file, it will be the overhead. Instead, why don't we check make something very basic. Right. So 0 is here, and the 1, 2, and up to 40, the 1. So we have the 42, the slot. Then if available, not taken, 0. And 0, 0, if taken, 1, 1, 1, 0, 1, 0, 1, 1, 1, 0. Then we may know easily which one is available, which one is not. Even how many available, right? Then another benefit of using such an approach is it's what? It's a bitmap. We call this one is a bitmap. Because what we need is 0 or 1. So this is 1 bit, which means 8 bit represent 1 byte. And if you have for example, the 64-bit word, okay? What is a word in terms of data structure?
Or
8 bit. 8 bit is the 1 byte. Then how many bytes? Sometimes it can be 8 bit is 1 byte is general, okay? But the number of bits for the word are different depending on what? Processor, CPU, okay? Depending on the CPU. So for example, most of the D word is the double word. Double word, how many bits? 16. And the Q word, quadratic, the 4, 32 bit. And some of them I nowadays use 64-bit word. Word is actually meaningful data structure. Byte is not meaningful because it's just 1 bit is too small, so we use 8 bit. Okay, because 2 to the power of 3, so we can represent easily using so 8 bit is the 1 byte, but 1 byte is not big enough to represent the meaningful information. So word is the smallest unit, the data structure to represent the meaningful. That service's name is word. Okay, the word is our meaningful, the natural language, the unit to represent, to express the idea, whether something knowledge, whatever. So similarly, word is a meaningful data structure to represent the information. Depending on the CPU, it may be various. Okay, so we can use the one word. So for example, if this one is the quadratic Q word, so 32 bit. So using just one word, we can represent how many blocks? 32 blocks. So if you create the 64 blocks in your, so you can use the 2 word. 2 word is enough to represent everything. Okay? Then, problem is, we need to search. The bigger size of file system you have, the more data you need, right? So it will take a time to search. The good news, we can use instruction. So if you remember, did you take the microprocessor class? Yes. In your sophomore, right? Sophomore? Where I think the sophomore second year, so we microprocessor class. So if you remember microprocessor class, you learned about some instruction. Among the instruction, do you remember? So you can easily find what is the left hand side? Bit. This is the most significant bit. And the right hand side, least. The instruction level, the CPU hardware level, it is where that is already implemented in the CPU, okay? So in your processor to calculate. So for example, shift to left, shift to right, and also to find first non-zero or the first 0 bit. It's not calculation; it's the hardware level implementation. So which means it's a very fast to find the first non-zero. So that is the instruction. Like find the first set. This is very popular. Find any of the first set of the data, set of the 0 or 1. Okay? Or so count the trailing 0 means count trailing 0. So this is the trailing is this side, the least significant bit. Okay, right hand side. The reason is the least significant is a value itself. 1 is what is the value? It's 1. But this one, 2 to the power of 32. Okay? So it's significantly, it's a half of the entire value. Okay? So that's the reason it's the most significant bit. So the trailing is from the least significant bit. Where is the first 0? Okay, how many? In other words, count how many 0. And the leading is this side, the most significant bit. What about the 1? I'd like to find the 1. You can just complement. Instead of this one, 1, 1, 1, 0, you can easily find. And also such a complement is also hardware level instruction. So it will be very fast to find using the CPU, the processor instruction level. So, for example, here we can manage such a bit map. So 1 represent, in this case, 1 represent free. Okay, 0 represent occupy. Okay, so opposite. So if we have the zeros, for example, so let's simplify the 8 block. 1 byte. So 0, 1, 2, 3, 4, 5, 6, 7. We have 8 blocks. So 0, 1, 2, 3, 4, 5, 6, 7. So 8 blocks. Then if the 0 is occupied, okay, 0 is used. 0, 1, 1, 1, 0, 0, 1. So first available contiguous, the available block is from 2, then how many? 3. Okay? Using bit map. So you can, what about the implementation? In your program language, most of the program languages provide such a bit operation. So you can count, you can use just a simple for loop if you want. Otherwise, you can use the bit operation, okay, to find first using such a most of the assembly languages, the instruction are implemented in the high-level languages. So you can use such the library in your program language to find this one. In this case, 3 contiguous available block. Okay. So then this one is nothing but in case the different size of word and many the word to represent, you can easily calculate. You don't have to read each and every bit. If you do not know how to do that, just read bit by bit using for or the while loop. Otherwise, if you are confident to use such a bit operation, so you can use the bit operation in your program language. Then you can manage the number of the free block. Okay. Then this is just a simple calculation. How many blocks we can manage? For example, in case the block size is 4K, 4K are the popular, not popular in operating system, but popular some of the application program, such as the database. So database use the 4K block size and so on. And then in case the disk size is 1 terabyte, and how many bits do we need? 2 to the power of 28 is divided by this one, right? 2 to the power of 40 is the space, the disk size, and to manage the number of blocks, so you can divide by the block size 2 to the power of 12, then that is the 2 to the power 28 bit we need. That is the size of 32 megabytes. So mostly, so this one also in-memory file system structure. So you can keep this information in your directory structure, but when PFS, any file system are loaded, we have seen the per system, the table, open file table per system, and the open file table per process. It's an in-memory file system to speed up. Similarly, we can load this information to the memory. Means you can just read the data, then the update, then from time to time, or at the end of your program, write back to your file system. Okay. Then another approach to manage the file system is, because we need to read every time how many available block and so on. What about the linked list? Which means we just manage the first available block. This one. Then this one link to next available block. And link to next. So we don't have to read each and every the available block or the search such a block, free block, instead only first one. Okay, to reduce the computation. So however, when we search the free block, it's okay, but to find the next, we need to read the next. Or not, this will be linked in the real block, like this one. So we manage the first block is number 3, like the 3. Then this one link number 3. And 3 has the next available free block, next available, next. So we can find. So this is the linked. Using linked list, we can manage the space. It will be good for contiguous? No, contiguous. We need to find the free block in a row. So you need to check until we have this one. So it may not be good, but it will be good for linked allocation, right? So we can just use this link for the allocation also. Okay. So I'm going to skip this. Nothing special. The grouping and the counting grouping is whether we can group the contiguous available block, which means instead of 1, 1, 1, or the link next one, so from here the 3 block is free contiguously. So that is the counting, and then using the counting we can group the available one and occupied one. That is the blank line. Sometimes such a free space management will be overhead. So there are different approaches, like the GFS use the space map. So they manage another data structure to manage like the physical hard disk drive, divide the certain the amount of data space and manage which one is the directory structure, which one is available route, which one is not, which is called the MetaSlab. The data structure, but I'm going to skip this part, so details, but this is another way to manage the free space, free block. Okay. Then we discussed about the most of the core part of the file system, but our goal of most of the time, our goal of the operating system algorithm is the first. Be fair. We need to share the limited resource to the process and the consumer. Then use the efficiently. So for the efficiency purpose, as we discussed a lot, in any computer system to speed up, we are going to use the cache. So similarly, file system use the cache a lot. So some of the hard disk storage, like if you purchase like the disk box, this is 5 terabyte. So then you connect to your PC, okay, using the USB, USB 3, and so on. At that time, some of the disk storage box include the buffer inside, memory. Okay, this one has a memory, so instead of reading all the data, it is true. So there is a 20-80 rules. So 20-80 rules in information theory is used a lot. What does that mean, 20-80 rules? For example, when I worked for the bank, so my old company, the bank was the first one in the country to offer the service for the VIP. It's not VIP, it's a VVIP. Because only 1% of the customer in a bank produce the 99% of the profit. That's still true, which means that if you open an account, that is actually just the overhead. So you will not contribute the bank. So even though you create a bank, only 1% of the customers create the 99% of the profit of the company bank. That's the so that bank will focus on only this 1% of the so-called private banker. So it's not general, but still the bank has the kind of the public contribution, so public service. Even though it's a private company, but it has the public service. Because of that, they cannot ignore any customer. So similarly, the classroom, I'm not sure whether that's the truth. Only 20% of students understand, and the other 80 not. So that's just kidding. In the data. The file system, think about this file system, the laptop is also. How many files do you have? Probably 100,000, 200,000, right? How many of them are using? Less than 1% probably, right? And also think about your cell phone. How many photos do you have in your, nobody wants to delete, then every time complain, out of space. So only less than 20% of data are used. The other 80% is just archiving purpose, backup purpose. Because of that idea, we have the clouding service. So just in case we back up the data clouding. It's the same thing in the hard disk drive. Only even less than 20% are used. So why don't we keep this data in the memory as a cache? That's the idea. Even though you probably heard about in the database, it's a memory-based database. Why don't we keep these 20% frequently accessed data always in the memory, like the SSD, even not SSD, it's a persistent memory. That is expensive, but we don't have to keep all this data. This data will be in the cheaper device. Even some of them are in the optical disc, like the CD or DVD. That's the reason some of the banks, if you want to retrieve your transaction history 3 years ago, they need to keep up to the 5 years, but they mostly keep the 10, 20 years ago the data also. But it will take a time. So you just request and wait a couple of days. It will be available because it's not online, but they are archived. So it may take a time. But they may not lose the customer because it's all the information for survey. So only this